Hi, welcome to Advanced Math, Chapter 12 on Vectors, Part E, page 5? I think this is page 5. Okay, we figured out a bunch of things about the Yorkshire Canary bird cage. We've got the heights of the corners of the roof, we've got the lengths of the edges of the roof, and now we're going to sort out what the one of the corner angles is on the roof. And that's one of the things that Zach needs in order to construct this actual roof. So the first thing we're going to do is figure out the angle at corner A, or vertex A of the roof. And that's going to be the angle between vector AB, or edge AB, and AD. So the two edges of the roof that include or incorporate corner A. So to start with, I'm just going to rewrite the components of those edge vectors that we came up with previously, I think on the last page. So this is just carrying those numbers forward. Now on the previous page we were looking at dA was the actual vector, and in this case we're going to write it as AD because we want these two vectors to start at the same place, start from the same point. Um, and so what I've done is taken vector dA and I've made the components negative so that I have vector AD. That's all. And we have the lengths of AB and AD, and the vector AD's length should be the same as vector DA's length because, well, they're just negatives of each other. Lengths don't change when you make it negative. So those are also things that we've recorded from the previous page, and these are in feet. All right, now we want you to remember something about vectors and the dot product. And there are two ways that you can write the dot product. So we've got these two vectors. So imagining we have vector u, which is a, b, and c, and vector v, which is p, q, r. You can express the dot product of those two vectors by multiplying the corresponding components together and then summing it all. Or, so this is one way of figuring out the dot product of u and v. The other way to figure out the dot product of u and v is to multiply the magnitudes of the vectors times the cosine of the angle between them. So if this numerator is the dot product of u and v, what you could do is set that equal to the other way of calculating the dot product, and then solve for cosine of theta. This is a way of figuring out what the angle is between the two vectors, what angle is formed by them, which, if you can figure out the angle formed between vector AB and vector AD, well, that's the angle formed at the corner of the roof. Yeah, really. So this equation here is the result of rearranging this to solve for cosine of theta. And once you've got this, we have everything we need here and here to evaluate this right-hand side. We could then take the inverse cosine of that to come up with the angle theta. So that's what we're going to do in the work below. So I'll write out this equation using the stuff that we know. So cosine of theta sub A, that's the angle at vertex A. And I'm just going to take the multiply like components. So 0 times negative 16 plus 18 times 0 plus negative 3.6 times 4.8 all over. Now the magnitudes are the magnitudes we came up with above. Those are the lengths of the sides of the roof. They're already positive. So 18.35 times 16.70. And if I put that in my calculator, this right-hand side, and evaluate it, I'm going to get cosine theta sub A equals about, let me say, about negative 0.0564. So then all you need to do is pop that into your calculator and say, give me the inverse cosine of negative 0.0564. And the calculator says that is about 93.2 degrees. And that's enough precision for, well, more than enough for Zach to actually cut that angle on his wood to build a roof. All right, so that's one of the angles on this roof. The next step is going to be to calculate another angle.